actually start the solving process until you understand the concept of how we're going to approach this. So right here, right, factor the left-hand side. We have two answers that said factor the left-hand side and then set the factors equal to 24. Most of us did not put the answer factor the left-hand side and then set each factor equal to 24. Why not? Someone who put something else, push back on that statement, or that answer choice.
Sorry.
The third answer choice was factor the left-hand side of the equation and then set each factor equal to 24, the right-hand side. Can someone push back on why we did not, most of us did not put that answer choice? We don't know why we didn't put that answer? Okay, we can't use the zero product property. What is the whole goal with the factoring method? To use zero product property. So can I just factor this and set it equal to 24? No, because it does not allow the zero product property. Okay. Notice the fourth answer choice was just factor the left-hand side, and I do want to point this out. Okay, first off, and I'm going to just work through this so we can get to today's lesson. Tevin, let's make sure we're off our iPad so that we can focus on the learning process, right? Okay. When I look at this, if I were to factor, what method of factoring are we using? AC method. Don't just stop there. It's the AC method of what? Of factoring. The ZPP, the zero product property, is later. The AC method is to factor these expressions, guys. Janai, you focus? Then let's look up at the board. Let's focus. Recenter ourselves. Guys, it's hard to learn if we are not focused. We've gone over this time and time again. I know some of us are bored, but most of us still have not mastered this. So we got to go over this a little bit more. Right? AC method of factoring. I need to factor, and I am going to go ahead and factor the left-hand side. I will point out, I don't want to factor the left-hand side, but it is still possible to factor this. Okay? The reason, again, as Ethan said earlier, the right-hand side is not equal to 0. So I don't want to factor, but it is still possible to factor. What is A in this standard form here?
X squared.
Be careful.
1.
X squared is x squared, right?
Yeah.
A is only the coefficient. How many x squareds do I have?
1.
1. So A is 1. C is 8. So AC method. A times C gives me 1 times 8 gives me 8. We'll go with the 8 there.
Excuse this interruption. We have a bus that will be arriving late this morning.
That might be part of it.
We will do our best to get the students' names and send them with some sort of pass to your class as they arrive. Just be aware that there will be some late students arriving due to a late bus.
Okay, so AC method. A times C, 1 times 8 is 8. Remember, now I need to rewrite this trinomial. What do I mean by trinomial? 3 terms, thank you. I need to rewrite it using how many terms? 4. I need factors of 8 that add up to what? I'll get there in 1 second, but I need the 8 to add up to what? Negative 6. So do I want positive 2 and positive 4?
No, you have to do negative 2.
Negative 2 times negative 4 is 8, and then when I add those, I get negative 6. So I rewrite this as x squared
Minus 2x.
minus 2x
Minus 4.
minus 4x
Plus 8.
plus 8
Equals 24.
still equal to 24. Right? I can still rewrite this standard form in the factored form. Remember, at this point, I don't want to combine like terms. The whole point was that I just split that up so that I have those 2 groups. And what do I need to identify for each of those groups?
What they have in common?
What they have in common, the greatest common factor. What could I divide out of both x squared and negative 2x? And x. Remember, x squared is literally x times x, so if I factor one of those x's out, what am I left with? An x. If I factor this x out, I'm left with minus 2. What can I factor out of negative 4x and 8? I can factor a 2, but is there anything greater that I can factor out? A 4 or a negative 4. So do notice, Jamarcus, yes, I could factor a 2 out, but I want the greatest common factor. Notice if I factor out a 2, so don't do this, but if I factor out a 2, negative 4x divided by 2 is negative 2x. 8 divided by 2 is 4. Do these match?
No.
So I don't want that, right? I want them to match. For those of y'all who said a positive 4, pay attention to this. Negative 4 divided by positive 4 is a negative 1x. 8 divided by a positive 4 is a positive 2. Do those match? So notice they are very similar, but because they don't match, I don't want a positive 4, I would want a negative 4. That's important. What is negative 4 divided by negative 4? 1, so I get 1x. A positive 8 divided by negative 4, negative 2. Notice the first binomial right there, that first set of 2 terms should tell you a lot about what I'm going to factor out of the second 2. Now don't just assume, check to make sure it actually works. But at this point, any common factors? So I look here and here, any factors in common? So I factor out my x minus 2. What am I left with? X. And if I factor out this x minus 2, I'm left with x minus. But notice what's the problem when I factor this way? It still equals 24, right? So the whole point was I wanted to use what property? I want to use the zero product property. I can't do that right now. So that's why this answer would not work. I can't just factor the left-hand side and then set each factor equal to 24. I can't use the zero product property. Notice here it says factor the left-hand side and just set each factor equal to 0, but is this equal to 0 right now?
No.
So can I do that? No. The last one here, make the right-hand side of the equation equal to 0. You have to start there. X squared minus 6x plus 8 equals 24. What can I do to make the right-hand side 0?
Subtract it.
Right, 24 minus 24 is
0.
0. Notice I had to use a property of equality. I can't change the equation permanently. I just need to change the way it looks so that it's still equivalent. Now I'm going to move through this a little bit faster, right? A is 1 times C is negative 16. That gives me negative 16. Remember, you have calculators to help you with this, but what are some factors of a negative 16 that would add up to negative 6? What was it? Okay. Some kind of negative somewhere. So 8 times 2 is 16. Obviously it's got to be a negative. Which of those needs to be negative to get a negative 6? Negative 8 plus 2 is negative 6. So x squared minus 8x plus 2x minus 16 equals 0. When you get comfortable with this, this starts to move real fast. First two have an x in common. Factor that out and I'm left with x minus 8. Second two have a 2 in common. I'm left with x minus 8. Now both have an x minus 8 and I'm left with x and plus 2. Now I can use my zero product property. The whole idea is if I'm multiplying two numbers and the product is 0, at least one of those factors has to be 0. Ms. Bauer and Mr. Kilpatrick and I were talking yesterday during fourth block, during my planning, and they started to notice that a lot of us are just saying zero product property, and that is an important idea, but don't forget, like, that is the name of an important concept. You got to understand what the zero product property says. Just saying ZPP, just saying zero product property doesn't help you. The point of that is that if the product is 0, then what? If the product is 0, then what? Say again. Okay, what things are being 0? Does that mean x is 0? But what are x minus 8 and x plus 2? They are being multiplied, so they are called factors, right? It's not just that we magically set those things equal to 0. The idea is that if the product is 0, then at least one factor is 0. So we set our factors equal to 0. Okay? Again, it's not just enough to know the name. You gotta know what it means. If we don't know what it means, then we're gonna be up the creek a little bit. Okay. We're gonna get plenty of practice, which is why I'm moving a little bit faster with this, but I do want to point this out. Agenda, why are we here? Phoebe, why are we here? To learn? Just learn random crap that we'll never use again? No? To learn what then?
To learn how to go into the world.
Okay, but like what does that mean? Let's be more specific. Naisha, off the iPad. Marshall, what's one thing we're trying to learn? Okay, so mathematics at its core is patterns and relationships, right? I will point this out. I haven't brought this actually up as a learning point, but are there patterns and relationships in your everyday life? Yes. Learning to make connections with those patterns and relationships is a useful skill, right? Learning to look for a pattern and look for how that pattern connects to other ideas is super, super useful. But it's not just something I'm always going to talk about. That is really from the math side of things, 100%. But come on, there's other stuff. Eliza, what are we trying to learn? Huh? Jacoby? What are we trying to learn? Okay, one thing we're trying to learn is social skills. He's not wrong. Why do you think I have you working in groups? One of the reasons is because we got to learn how to what? Talk with people. We got to learn how to be respectful. We're going to get to that one in just a second. But I'm talking about like that social skills side of what Jacoby just said is important. We got to learn how to talk with people and interact with people and learn with other people, because you are going to have times in your life when you are the expert in the room and you need to share your ideas with others. There's going to be times when you're at a job that you are going to be the person who has to ask questions. This is an important skill long term. So the same thing's going to happen in college, for sure. Now, Naisha did say one important thing. We got to learn how to what, Naisha? Think. Right? I'm trying to teach you how to create arguments, the idea of thinking, because that's a useful skill. Alright? Trayana, what are we trying to learn? For real? Like we just talked about it. Are you engaged? Are you thinking at all about what we're talking about? Eliza, give us one of the things we just said. What are we trying to learn? Social skills. We got to learn how to interact with people, okay? Shania, what's the other thing we're trying to learn how to do? Besides sleep? Ethan, can you help her out? We're trying to learn how to think and create arguments, guys. Come on. We got to wake up. We got to get going. Now, we are going to have to move around to the vertical surfaces in a second so that we can wake up, because, man, we seem dead. All right, homework questions. Some of y'all are lucky because I'm going to go out on a limb and say some of us didn't even look at the homework last night. And Lily Kate brought it to my attention that I identified the wrong page, so there might have been some confusion with the homework. Hopefully we found it and realized I told you page 90, but I meant 91. So we're going to look at those questions. And then we're going to do some more solving quadratic equations from the book and everything else. Quick understanding check. That's not a grade, but a true understanding check. Whew, that's a lot. All right, we're going to get there. So here's, I asked you to do A and E, right? For those of us who attempted it, one, get out your book or get out your work. What questions do you have about these? We should have our book in general because we should have notes about factoring there. Come on, Shania, wake up, please. Thank you. So M191. So I showed a couple of steps. Not all of the steps. What questions do you have about this, Miracle? Where's your textbook?
I took it out of the spring break, and I locked my backpack.
Gotcha. Let's make sure we put it in there tonight.
Can you just tell us we have homework?
Did I tell you? Yes.
Oh, let me hear.
Yes, I definitively told you you had homework. I even paused an extra minute before the bell rang to make sure I put it up on the board. Yep. So, yep. I assigned it, I told you, because y'all groaned, there was a collective groan throughout the room when I said that I asked you to do 2 problems. Just a heads up, Tyson, that's volume 2, not volume 1. We need volume 1, okay, M1-91. So, I just asked you to do A and E, right? AC method of factoring. For those of us who attempted it, any questions about these two? There are no questions, we're going to move forward in a second. Again, I didn't show every step, but I showed a few of them to get there. E, yeah.
Wait, don't move yet.
Okay. So E is definitely the more complicated of the two. Do you know what makes E just a hair more complicated than the other one? That 3x squared. The A being something other than 1 makes it a little bit more complicated, but if you use the AC method, it doesn't really change anything, right? First off, remember, you do want to look for a greatest common factor, but do 3, -22, and 7 have any factors in common? Can I divide any of that by the same number? Nope, definitely not. So then I move to the AC portion of the AC method. So, A times C. So A is what? A is 3, C is 7. So I get, alright? So A times C, 21. What do I need to do with that 21? Well, not factors of 7 and 3, factors of 21 that do what? Add up to -22. It's got to add up to B. Remember, we're trying to go from 3 terms to how many terms? 4 terms. So I need factors that would add up to this. I'm rewriting that -22x. So, what are factors of 21 that might add up to -22? Huh? -1 and 21?
No, what is it, -21 and 1?
I want them to add up to -22. They can both be negative, Eliza. They don't. One doesn't have to be negative, and one has to be positive. I will point this out. They actually need to multiply to give us a positive 21, right? If it was this, would that multiply to give me a positive 21? No. When it's a positive, they both have to be positive. They both have to be negative, and they both need to be negative, so they add up to -22. And I will remind you, it doesn't matter what order you put these in, right? It'll work out the same either way. But that means 3x squared stays the same. How am I rewriting -22x? So -1x, or just even minus, yeah, let's do -1x. Minus 21x equals,
Why are we keeping it the same?
what do you mean?
3x.
Well, I mean, I'm not really changing anything. If you look at it, that's 3x squared, right? -22x, is that the same as -1x minus 21x? So remember, I'm trying to just rewrite this middle term so that I can have those 4 terms that I'm going to factor the GCF out of, right? I need those pairs. And I will also remind you, Sanaya, actually let me ask you this, what is factoring undoing? Distributing, right? So notice, if I do x times x, that gives me x squared. If I do x times -5, I get -5x. 3 times x gives me plus 3x. 3 times -5 is minus 15. After distributing, how many terms do I have? 4. And please note, this is not the same problem. I did that intentionally. But when I distribute, I get 4 terms. Then I simplify to get down to 3 terms, right? So here I have 3 terms. I need to get 4 so that I can then factor, right? The whole idea is that the A and the C are staying the same. I'm just splitting up that middle term because that's what I added together after I distributed. So I need to figure out what was this originally so that I can factor. So 3x squared minus 1x. Common factor is x, right? I can divide an x out of both. So then, if I factor out one of these x's, what am I left with?
3, 2. Oh, I'm choosing.
So remember, I'm factoring out the factors. That's 3 times x times x. I factored out that x, so I'm still left with 3x. I factor out this x, so I'm left with negative 21x and 7. What do they have in common? 7. So I factor out, should I factor out a positive or a negative 7?
Negative.
Now I want that negative 21 to become a positive 3. So I need to factor out a negative 7. And when I take negative 21x and I divide it by negative 7, does that give me a positive 3x? And that's what I wanted. When I take a positive 7 and I factor out a negative 7 or divide out a negative 7, what am I left with?
Negative.
So 3x minus 1. If these are not the same, I can't move forward. But they are the same, so I can move forward. What would I now get?
38 minus 1. Yeah, 8 minus 7.
And then those are factored out, so I'm left with x minus 7. I have a factored form equal to 0, so I can use what property?
Zero product.
Zero product property. Right. Set your factors equal to 0, and then solve. Finish solving. I trust that you can finish solving for x from here. You would get x equals 7, and x equals 1/3, right? I would expect you to show those steps, but for the sake of time, does that answer all your questions you had though about E? Okay. So we need to move to vertical surfaces to finish factoring a hair. I think actually y'all have only one more problem left. That's the only one. Alright. So we have a factoring problem here. Locate, work with group 4. Everyone else should be able to work in the groups they have. So group 4, you'll be up here on the vertical surface. Everyone else just go where you normally would go. Sound good? Everyone knows where they're moving to? Alright, I sent out the poll question. Huh? What about them two? They're alright. Alright, let's get up, let's move to our vertical surfaces, and let's actively collaborate. Yeah, if y'all, group 3 and 7, if y'all want to work together, it's only 5 people, I'd be fine with that. But, use the problem on the calculator, let's actively collaborate, let's get it done. Okay. Okay, just good.
Appreciate it, man.
Negative.
90.
Don't hit it.
Yeah, hold on.
That's not a factor. What's the factor? What do we do with factors? Where do you see factors being multiplied up here?
No, we here, I already know that.
Nothing is being multiplied.
Damn.
Keep it going.
Dang.
That's your factor form. X minus R1 times X minus R2, right?
Don't say such a thing.
Okay.
Why, who would say that though?
Start this, yeah. Alright, so I need to address a couple of mistakes that I'm seeing. We're getting better at the actual factoring process. That's good. But I need us to pay attention to a misconception that we have when we're doing our work. What is the first question that was asked on the calculator?
The fact.
Just the factored form, right? So when I walk over here, what's here right away that was not in the calculator? Yeah, did I originally have an equal 0? So that's jumping to the solving process. If I only ask you to get the factored form, I'm only asking you to go from this standard form to this factored form. That's it, right? That's something I need you to pay attention to. We gotta just go from standard form down to factored form. You stop there, you're done. Okay? Now, can you grab the door? I do want to ask, because I think we all got there, does anyone have a question about that factoring process? What are your questions about actually factoring? I know some of us made mistakes, but then we realized it was just a small procedural mistake, right? And I need y'all to pay attention to that. Just making a small procedural mistake that gets you stuck, don't erase it, don't stop there. Hold on, I'll come over and I'll check on you, right? Keep it going though, persevere through that. Now, I want to point this out. In this group, we need to pay attention to a small but serious mistake. They went from a factored form to two equations. Using what property? Zero product property. What's the problem with this work in using the zero product property? Why not? Yeah, is this equal to 0 right now, guys? Eventually, are we going to get here? Yes. Did they have it set equal to 0, though? You've got to pay attention to this, ladies and gentlemen. So when I look at this, here's my factored form. And then you need to do a second problem, at least in this case, because I set it up as two different problems. It equals 0. Now, do I need to go back through all the work to get the factored form? What's the factored form of this? X minus 2 times 2x minus 7 equals 0. Now I have it set equal to 0. Now I can use what key property? Zero product property. But Sanaya, what do I mean by the zero product property? Huh?
Equal to 0, like this.
Why? Now, is she correct that we're going to set x minus 2 equal to 0 and 2x minus 7 equals 0? That's called a procedure. Yes, that's what we're going to do. But you've got to understand why. On assessments, am I going to expect you to tell me why?
Yes.
Yes, very much so. So we got to pay attention to this. Let's see. Shania, you look really engaged. Why are we doing that zero product property? What does that mean? Put the iPad away. Thank you. Jamarcus, can you help us out?
What was the question again?
What do we mean by the zero product property?
What's the name equals to 0? I forgot what it's called.
How do you think about the name? The zero product property.
The
what?
product is equal to 0.
Oh, the product is equal to 0. Are we multiplying things?
No. Yeah.
Remember, there's an understood multiplication between those parentheses, right? That's what a product is, multiplication. Is the product 0?
Yeah.
Yes. Because the product is 0, what do I know?
One is 0.
At least one of the factors equals 0. It's not just randomly setting those parentheses equal to 0. The idea is if the product is 0, then either this factor, x minus 2 is equal to 0, or this factor, 2x minus 7, is equal to 0. That's the principle. The zero product property says that product is 0. And maybe I should show this as well. First off, continue solving, right? X equals 2. Now notice this group stopped. Did y'all just run out of time? Or did you think you were done?
I just forgot to do it.
Okay. Notice, have we finished solving for x if we say 2x equals 7? Nope. What do I still need to do? Divide it by what? Okay, so I'm going to use that reciprocal, times 1/2. So 2 divided by 2 is 1, x equals 7/2. Here's why this is important, and why I want you to understand this. If these are solutions, they need to make that equation what? True. Let's substitute that 2 in. Now remember, if I substitute 2 in, I'm substituting 2 in for x everywhere. Pay attention to this. Okay, what is 2 times 2 minus 7? You have calculators. It is -3, okay. But you also have calculators. What's 2 minus 2?
0.
And what is 0 times -3?
0.
That's 0. That's the zero product property. At least one of the factors is what?
0.
0. The 2x minus 7, I got 7/2. So I'm going to substitute 7/2 minus 2. There's my x. 2 times 7/2 minus 7. Most of the time, guys, a lot of us are going to think, hey, I have to put that right-hand side into the calculator. But if you understand that that fraction bar means what? Division. What is 2 divided by 2? 1. What's 1 times 7? And 7 minus 7 is 0. It doesn't even matter what the left hand, or this left expression is. What's anything times 0? 0. That's the zero product property. Those two numbers make the equation true. So that means those two values are what? Starts with an S. Solutions. The whole point is that a solution makes the equation true. And if we can factor and use that zero product property, we can solve. What are your questions before we continue? Yes, ma'am.
I don't understand that, the X is like, you factor out the X.
Right here when I factor out the x's. Okay. So there's two different ways to think about it. And so I'm going to show you both, see which one you feel more comfortable with. Remember, factoring is the inverse of what? What is factoring the inverse of, guys? Multiplication, right? Which is why it's the inverse of that distribution, because distribution is the idea of multiplying. So when I look at this, and I look at these first two, do you understand first how to identify that the x is a common factor? Okay? So they both have an x in common. And I'm going to factor it out. Factoring is the inverse of distribution, or inverse of multiplication. How many x's are being multiplied here? 2, right? How many x's am I dividing by? 1. So the 2 is still there. I have 2 x's. I divide by one of them, so I'm left with what? 1x. So I'm left with 2x. Notice, what is x times 2x? Right. So I've factored out that 1x. If I take the negative 7x and I divide by x, what is anything divided by itself? Anything divided by itself is? Isn't 5 divided by 5 is what? 1. 17 divided by 17 is 1. Right? X divided by x is 1. So I'm left with minus 7. So that's one way to understand it. Okay? Another way to understand that factoring process is to think about the factors here. Factors are things that are being multiplied. 2 times x minus 7 times x. If I factor out this x, I'm factoring out this x at the same time. What am I left with? 2x minus 7. So you can do that division process either in your mind or writing it down, or you can write out those factors and you mark out the factors that you're factoring out so that you know you're left with 2x minus 7. Either one works. Do either of those help you? If not, I'm going to have to go to the drawing board and think about other ways to explain it. That's the best way I can explain it. Any other questions? Okay, we're going to get some more practice problems with this. Alright, from here, textbooks need to be out. If you don't have your textbook, you'll need to look on with somebody else. That's not mine. Why is still on my remote, man? That's just rude. Alright, oh, I just blinded. Did someone steal my eraser too? Disrespectful. Alright. So we're looking here at Module 1, Topic 1, Lesson 5. The whole point is solving quadratic equations, okay? And so we are here on page 81, I think? No, I think it's 82, actually. Okay? So M1-82, is that correct? Yes, okay? So, 82. Next page. 82. There you go. Okay, so on M1-82. So here we are using factoring to solve each quadratic equation. First things first, I do want to make a quick change here. I want you to rewrite C as just 2x squared minus 5x equals 0. I think the fractions make it unnecessarily complicated for what I'm expecting. So just 2x squared minus 5x equals 0.
We already did A.
Say again.
Then we already did A.
Did we already do A?
Yeah.
Yeah.
Okay. It looks like we started A. Did everyone finish it?
Yeah, we
No, we
did finish.
finished it.
We got
X
X
equals
minus.
2 and X equals 6.
X equals 2 and X equals 6?
Oh.
Shemai looks like he's gonna kill you. The other thing I do want to point out here is, notice, is this just a quadratic equation?
No.
What would we call this? A quadratic function, right? It's got that function notation, okay? You're not gonna solve quadratic functions, you're gonna graph them or make a table or something like that. So to make this a quadratic equation that we can try to solve, bless you,
Ooh.
make it 0 equals,
Bless
okay?
you, boo.
So go ahead and make that a 0 equals. Okay. And so do notice x minus 6 times x minus 2, that's the one y'all already did. So x equals 6 and x equals 2, okay? So I want us to get to our vertical surfaces. I want us to go ahead and work on B, C, and D. When you finish one of those, leave your work on the board so that we can see it and have a whole class conversation. But let's knock out all 3 of these together, okay? So let's get up and let's start actively collaborating better than we started last time. Remember, learning is a collaborative and social experience. It's not something that we should be doing on our own, because more ideas are better. It's going to help us learn and grow better. All right, let's get up. Let's start moving.
You know what?
Leave the problems up on the board.
Nobody can go wrong thing right now.
You buy me one? Thanks. My birthday coming up.
Maybe not so much water this time. You just have a little bit to erase anyways. Come on, let's make sure we're actively collaborating, right? Naisha. All right. Hey, let's grab a seat. We're going to talk about these problems. There's Alrighty. So first off, I am super proud of all the groups for recognizing the most important first step for B. What did you have to do with B to get started? You had to add 7. Okay, guys, I'm going to give you time to take notes on this in just a second. Pause on the writing. I'm going to talk through each problem. After I finish talking through the problem, you can write some notes. Why did we have to add 7 on the right-hand side? If I want to use, what's the goal? What's the property I want to use?
Zero product property.
If I want to use the 0 product property, that equation has to equal 0. Now I need y'all to be careful. Look at this equation. What mistake did they make? They ended up correcting it, but there's an important mistake that I see right here.
Oh, baby, I was at Jackson.
Huh?
Right, well.
Say again.
Right, well.
Still have to do plus 7 where?
No, we still have the plus.
No, you should have the plus 7, right? -7 plus 7 is 0.
And it ran to 0 now.
Well, so yeah, we do need the equal 0. I will say that. Where?
No.
You had told her.
I'm going to talk about that in a second. I'm actually talking about right here.
Then I add 7 to both sides?
Ooh, aren't we supposed to, whatever you do to one side of the equation, we have to do to the other? And so you had it here, but guys, please pay attention to this. That's a property of equality. If I add 7 to the right-hand side, I need to add 7 to the left-hand side, and I need to show that, right? You corrected it, and you showed it here, but I am expecting and looking for that plus 7 right there. X squared plus 8x plus 7 is equal to 0. We all correctly identified 1 times 7 is A times C, that we needed 1 plus 7 to add up to 8. Right? And then we factored. Now, Tevin did point out an important thing that I do want you to pay attention to here.
That is a 7.
That's a 7, I'm aware. What's happening between these parentheses and this 7 right now? Well, right here they're being multiplied. If you don't put that addition symbol, it's being multiplied. Make sure you put the plus 7. I know that you got to the correct answer here, but if you don't put that plus 7, it will catch up with you and you'll make a mistake at some point. Be careful and make sure you factor out that positive 7. What?
size method.
It's fine. But we just need to learn from that. And here's the thing, even if you didn't write it, aren't you supposed to catch it? We're actively working in a group. We're helping each other get better at these skills. Okay? All right. If you want to write down the answer or the work in your book for part B, this would be a great time to do that. Make sure that you have that down. Dennis, like, I'm good at this. I don't need to write something down. Yes, ma'am. Can you get a what? Like a paper towel? Alright. How much longer do you need to wait? 60 seconds max? Or we already have this written down? Quick show thumbs up if you're already done writing. Yes, ma'am. Alright, thumbs up.
No, you take.
Group 6, how many of us are done writing down?
I'm almost done.
You already done?
We did it when you were.
Okay. Group 5, everybody done writing down? Any questions about this one before we continue?
No.
Okay. I know that with C, we slightly freaked out with C, right? Some of us. But I want to focus on and remind us, y'all are good. It's mostly focused on the board. You're good. I want to look at this again. Okay, so attention over here. Where did that chalk go?
He's right down the corner. Oh.
Okay. So let's look at this.
You're a mess.
Look, you cannot forget your first step. The true first step with that factoring by the AC method is to factor out your what? Greatest common factor, right? When I look at 2x squared minus 5x, don't they both have an x?
Yeah.
Notice, this is the same step that y'all are taking right here. You have two terms, and you're identifying the greatest common factor, and you're factoring it out. So I factor out that x times 2x minus 5, and that equals 0. And a few of us got stalled here, but we have to pay attention. Do I have a product? What do I mean by product?
Yes.
Well, hold on. But just, yes, but what do I mean by product? How do I know that I'm dealing with a product? Yeah. Guys, are these things being multiplied? Yes, that's how I know I have a product. What is my product? So what can I use? Zero, product, property. Right? If I have a product equal to 0, I'm using that 0 product property. And so we set 2x minus 5 equal to 0. Added 5 to both sides. And then you got x equals 5. Anybody get anything different?
Wait, it's okay, 5 and 2.
5
Divided.
divided by 2, 5 halves.
Yeah.
What's the mistake that was made right here that we need to learn from?
We didn't actually do it to both sides.
Yeah, we gotta have that property of equality. Look, if you substituted 5 into this equation, it would not make that equation true. You gotta use your property of equality. So 5 halves. Now I need to point out a second detail that's important. Usually with quadratic equations, how many solutions do I have?
2.
Where's your second solution?
0.
Oh, you wrote it over here. I missed it. Good call. But make sure that we do times 1/2. So do notice the first factor, x equals 0. The second factor, set equal to 0 and solve. Questions, comments, concerns? We're rocking and rolling.
Yeah, let's give it to the front.
Okay? Get it off our work. Questions? Make sure you write down C. And then we're going to talk about D.
CD. Like.
Huh? Rakai, it is literally above your head. Chill. Grace is alive! Just here for a really important discussion. Okay. Right here. I want us to focus on what this group did. Actually, who's still writing C? Jamarcus, you done?
I'm done.
Okay, so I want to point this out, what this group did with C, and a bunch of the groups who got here started to notice this, right? I think group 7 was like stressing, they're like, I don't know what to do. We did A times C and got 12, and then we start looking at the factors of 12. Do any of those factors add up to 10?
No solution.
No, well, it's not no solution. That's a tempting thought here. That's a good thought, but it's not no solution. It's actually not solvable by what? Factoring. And Jamarcus had a brilliant idea. He said, well, if I cannot factor, what method could I use? What?
That's Jacoby.
What did I say?
Jamarcus.
I said Jamarcus. Jacoby, my bad. Jacoby, what did you say we could
Lately, I've
do?
been on your mind.
Huh? Hey guys, we've been going from standard form to factored form, right? But can we also rewrite it in vertex form?
Oh.
Because if I have vertex form, what can I do to solve that equation? Inverse operations with properties of equality. Sometimes you can't factor. And when you can't factor, we're going to make vertex form, okay? So let's look at this one really quickly. All right? Notice right here, we wrote out that vertex form, right? And when I look at this equation, when I look at standard form, and so again, remember, we got to know our equations. Guys, you've got to know factored form A times x minus r1 times x minus r2. You've got to know standard form ax squared plus bx plus c. You've got to know vertex form. If you have not learned those equations, you need to take the time to memorize them. But when Jacoby wrote out his vertex form, and we look at this standard form, does anyone know what A is right away?
Yeah, 1.
It's that 1, right? That's why he wrote a 1 there. Now the tricky part is remembering how to find H when I have standard form. How do we calculate H from standard form?
Wait. Oh, what is it?
Oh, is it Nate?
No,
I thought I wrote it up here.
B divided by A? Something like that.
Oh,
Negative B divided by A.
2. Yes,
2A. Okay, I was somewhere.
Negative B divided by 2A, that is how I calculate H. So what is B?
1.
Oh, I'm sure you said B. I'm sure my bad. 10.
So I have the opposite of B is negative 10. Divided by 2 times, what is A?
1.
So what is H?
5. Negative 5.
Be careful with negative
I'm
5.
done.
So notice x plus 5 squared, right? Now, we need to be careful because we did make a mistake right here when we substituted in. Remember, K is just the output for an input of H. Notice that language. If this is my input, what am I going to do? Substitute it in, right? That's my input. Remember, though, I need to put negative 5 in parentheses. I'm squaring a negative 5. Well, because there was a small mistake. What is negative 5 squared? Positive 25. That's where I made an error right here, right? When I square that negative 5, I need a positive 25. What is 10 times negative 5? Negative 50 plus 12. That gives me a negative 13. So that is what K is. So very, very close. Great idea. But this is the equation I should have. Right? So when I look at D here, Jorgis, can you turn that camera for me so it's facing up here? So when I looked at this equation, can I ever solve it in standard form? Can it see the board? Okay. I can't solve in standard form. We tried to factor. Could I factor? No. So if I couldn't factor, I'm going to create what form? Vertex form. And so we went through the work over there, but what we found out is that this is the vertex form. That's the vertex form. H was negative 5, so x minus negative 5 gave me x plus 5. K was negative 13. What would I now do to solve this equation?
Added 13.
Add 13. 13 is equal to x plus 5 squared. Now,
The mother changes that one, divided by.
So remember, that's already 1 times. The whole point is to make ones, right? Do I even need to write the 1 there?
No.
So positive negative square root of 13 is equal to x plus 5. Now, I'm almost done. Positive negative square root of 13 is equal to x plus 5. So what would I do?
13.
Oh, yeah, subtract one.
I want to subtract 5. And I would leave it as negative 5 plus or minus the square root of 13. That's it. When I cannot factor, and that's what I would make a note to myself right there on D, is this. When I cannot factor, try creating the vertex form. When I cannot factor, right there on D, I would make that note to myself. When I cannot factor, I'm going to create what form? Vertex form. Okay. And that's actually what activity 5.2 is all about. When I cannot factor, I'm going to create that vertex form or convert it to vertex form. Okay? I want you to get out a sheet of paper. I want you to try solving these 2 quadratic equations on your own. Try solving these 2 quadratic equations. This is that quick understanding check to see how well we understand this. So, notes up, just a sheet of paper out. Not a grade. I need to see who is understanding what so I can support you better tomorrow.
Are you taking these up?
Yes, I'm going to take them up so just so that I can look through it. Not for a grade, so show me what you
They
understand.
need to be for a grade. I'll do anything.
Why would it be good for me to give you a grade if we don't do it well?
I'm saying like a
But what if we do it well?
You get a participation grade every day, active collaboration. And we did pretty well.